Hi. Spoken language recognizers have been around for a long while. On the left-hand side, an IBM engineer is demonstrating a recognizer in 1961. And since then, the technology never stopped improving. Hidden Markov models are a mainstream statistical graphical representations for model vector sequences in the temporal domain. And it is commonly used in almost all speech recognizers nowadays. The advancement in machine learning and deep neural networks based sequence models offer alternatives for the current design decisions, and novel learning and representation methods enable better language and acoustical models. And moreover, large data sets, open source toolkits, and computational infrastructure are publicly available right now. As a result, I came up with the idea of comparing HMM-based models with the novel deep neural networks as my term project. I previously had some experience on HMM-based models, but I had no experience on deep neural network or sequence models earlier. And so I talked with my mentoring TA, and we decided to start from the data and pick one of the available deep learning frameworks, and we picked deep speech framework as our start point. We picked four data sets. One is a large, very well known data set, which is called Switchboard, and I had experience of working on that data set. And second one is a timid data set, which is a little smaller. We call it mid-size. And next one is TIGITs, and we have another test data set for recordings and manual transcription of radio weather message broadcasts. We combine all these data sets and start working on our high-level design, how to use and how to tune, how to set up the environment and how to tune the recognition system. I started working on the corpus, especially with the audio files. Their sample rates, bit rates, and number of channels, stereo or mono, was not the same. So I realized that I need to make a pre-processing stage where I convert all these audio files and split them into smaller utterances. The data size was huge, so I generated this as a separate pre-processing stage. After the data is getting processed, I had multiple smaller subset of data sets, and I started with the timid smaller subset, and I trained the first model. And multiple iterations I tried and it didn't work. Then I realized I need to print the learning curve, and it worked. And the number of epochs, number of hidden layers, early stop, or dropout rate, learning rate are the hyperparameters, some of the hyperparameters that I played with and came up with a good number and used that number for my training set. And in conclusion, I compared two models based on word error rates. I used a score called SC-Lite, which generates the word error rates given the hypothesis and decoded transcripts. And I got great results. The HMM Sphinx, I had reached 41.8 word error rate on unseen data as the best result in 300 hours trained and decode on full set of switchboard. And on the new model, I came like with a 55% word error rate on test data, which is great for my first try. And moreover, I kept working on it, and I achieved a 20% for word error rate on test data of timid corpus based on the pre-trained model with switchboard, Fisher, Libre speech, and common voice English corpuses. And I reported those results on my paper. As a future work, I would like to continue working on the experiments, and I would like to complete all experiments that I designed earlier. I never had time, and more importantly, I ran out of budget on AWS to run those experiments. And during my readings, I saw and I took some notes about the augmentation on deep speech framework. It is available that you can manipulate the background noise, reverb, add reverb, or gap removal, or other methods that can augment the data. And I would like to delve deeper into transfer learning technique in order to improve the training efficiency and decrease the cost. Thank you.